Hello dear students, in the last class we studied regarding the hybridization of carbon atom and we assigned the hybridization of each carbon atom in the given example. So today I am going to start the next point from your syllabus, that is structural representation of organic compound. So whatever the organic compound is there, that organic compound, they are represented in the following manner. So whatever the organic compound is there, they can be represented by Levis dot structure. Second one, dash structure. Also it is called dash structural formula. Third one is condensed structure, or also it is called condensed structural formulae. Fourth one, bond-like structural formula. Also it is called bond-like representation of the organic compound. And next one is the three-dimensional structural formula, or also it is called three-dimensional representation of the organic compound. So first of all, we are going to discuss the first one, Levis dot structure. By using the Levis dot structure, one can write the Levis dot structural formula. In the Levis dot structural formula, each covalent bond is represented by pairs of dots, and whatever the dot is there, that dot it indicates the electron. As you know that whatever the organic compound is there, that organic compound formed by covalent bond. As you know that, so whatever the bond is there, that bond formation takes place by having two electrons, and that bond, that is one bond, indicates one pair of dot or one pair of electron. Two dash or two bond indicates two pair of dot, that is a two pair of electron, or three dash indicates three pair of electron. So likewise, one of the example we will discuss right now. Example I shown as a methane, CH4. This is also it is called dash structural formula or complete structural formula, where the central atom is carbon is there, and around the carbon atom 4 hydrogen is bonded by covalent bond, and this particular structure it is called Levis dot structural formula. So whatever the carbon hydrogen bond is there, that covalent bond it showed as a pair of dots. That dot indicates the electron. Second example I will write the simple example, C triple bond CH. This is the ethyne. So here how many bonds are there? Total here 1, 2, 3, 4, 5. Here 3 sigma bond and 2 pi bond is there. How one can convert this Levis dot structure? I will write this one. First of all, you have to write a carbon. Across this carbon, triple bond is there. 3 dash are there. Each dash or each single bond indicates that one pair of bond. Likewise, 3 are there. So I will represent 3 pair of dots. And carbon hydrogen is there. Carbon hydrogen I will show also covalent bond. Here also carbon hydrogen is there. That also I will write in the covalent bond by dot form. That is a Levis dot structure. So likewise, you can write Levis dot structure. Second way, that is called dash structural formula, or also it is called complete structural formula. So in this case, in this method, each covalent bond is represented by dash. Here, one dash is used to indicate single bond. 2 dash is used to indicate double bond, and 3 dash is used to indicate triple bond. Let us discuss an example. So I show an example here. The name of the compound is methane, CH4. So CH4, it is condensed formula, but in the dash structure formula or complete structure formula, whatever the carbon hydrogen or carbon other atom, they are shown by dash form. See here, carbon hydrogen, carbon hydrogen, carbon hydrogen, carbon hydrogen. This is called gas structure formula or complete structural formula. Next one here, see here, CH3, C double bond O, OH. This is called acetic acid. Where what is the carbon atom, what is the methyl group is there, where on this carbon atom 3 hydrogen atom is there, they are bonded by single dashes. These carbon they are bonded by single dash. Carbon and oxygen, and the carbonyl group is there, they are bonded by double dash, that is double bond. And here also carbon oxygen bond is bonded by a single dash, oxygen hydrogen bonded by a single dash. So these particular structure also is called complete structural formula or dash structural formula. Another example, third example is the name of the compound is ethyl. So where carbon carbon is shown by 3 dashes. What indicates 3 dash? 3 dash indicates that the compound is having triple bond, and carbon hydrogen also is shown as a single dash. So next we are going to discuss condensed structural formula. So in this structural formula represents by omitting some or all the covalent bonds and by indicating the identical groups as subscript. Example, CH3, CH2, CH3. So in this particular example, CH3 and CH3 are identical groups, similar group. They are 2 times repeatedly is there. So that's why CH3, CH3, and can write in the bracket by 2. What 2 indicates? 2 indicates that how many times that identical group is repeated, and that is written by subscript and CH2. Another example, CH3O, CH3. So in this example, these CH3 and CH3 2 times is there, so that's why I can write in the bracket CH3 twice O. Third example, CH3, CH2, 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 CH3. So in this particular example, methyl group and methylene group is repeatedly present. CH3 group in this particular group is 2 times repeatedly is there, and CH2 group is having a 4 times. So I can write CH3, CH2 4 times repeated, CH3. This is the one of the way to represent the condensed structural formula. Another way to represent the condensed structural formula, where the similar atom or similar groups they are brings together, and how many times they are repeated, that number they is to write by a subscript. For example, in this particular compound CH3, CH2, CH3 is there. So if you look towards the example, you will find 2 atoms are similar. Which are the 2 atoms? Carbon and hydrogen. So see here, in this particular example, 1, 2 and 3. Whatever the carbon atom is there, that carbon atom is repeatedly present by 3 times. So that's why I can write as a subscript as 3. Next, hydrogen. How many hydrogens are there? 3, 2 and 3. Means total in this example 8 hydrogens are there. So I can write C3H8. This is another way to represent the condensed structural formula. One more example is there, CH3O, CH3. If you look towards the example, we will find three different atoms are there. Which are the three different atoms? One is their carbon, another is their hydrogen, another is their oxygen. So carbon and carbon two times repeated is there. So that's why I can write carbon and 2 number I can write as the subscript as a 2. Hydrogen CH3, these H3 and these H3, total 6 hydrogens are there. And only one oxygen is there. This is the another way to represent the condensed structural formula. Similarly, you can try for these examples also to write the another way of condensed structural formula. I'll come to next. Bond line structural formula, or also it is called bond line representation of the organic compound. In this method, carbon and hydrogen are not shown, but only the bonds between carbon and hydrogen are shown by lines. The ends of vertices represents the carbon atom, and in this method, whatever the bond line is there, they are drawn by zigzag line. Means in the bond line structural formula, they are not shown atoms. If it is having a heteroatom, apart from carbon and hydrogen, any other atom is there, they can write as it is. But if the carbon and hydrogen atoms are there, they are not shown on the line, but they are shown by a line, and they are shown by a zigzag line. For example, I show one of the zigzag line. Okay, so here I showed as a zigzag line. In this particular example, you will find two ends, two terminals there. This one and last one. Remember, each end indicates the carbon atom, and whenever the junction is there, whenever the vertices is there, whenever the two lines join, there also carbon atom is there, and whatever the carbon atom is there, that carbon atom, they are satisfied balance. Means you have to write the necessary number of hydrogen atoms present in their structure. See here 8 is there, so here carbon atom is there, here also two lines are joined, here also carbon atom is there, here also two lines are joined, here also carbon atom is there, 8 is there, I can write as the CH3. So how you can convert in this structural form? So whatever the bond line formula is there, bond line representation is there, you can convert in the structural form. How we can write this one? See here. First of all, you have to write down the number of carbon atoms present in the system. 1, 2, 3, 4. I'll write here first of all. 1, 2, 3, and 4. Is there double bond? No. Is there triple bond? No. So whatever the carbon atom is there, that carbon atom you have to satisfy its valency. So how to satisfy the valency? You have to write the necessary number of hydrogen atoms. As we know that we studied carbon, it is the tetravalent. So here I should write 3 hydrogen atom, here I should write 2 hydrogen atom, here also I should write 2 hydrogen atom, and here I should write 3 hydrogen atom according to the valence rule. So this is called structural formula, and this is called bond line structural formula. So let's discuss right now how to represent some of the example in the bond line structural formula. So right now I will write the structural formula, and by referring the structural formula, you have to convert it into a bond line structural formula. Let's discuss the example right now. I'll write here CH3, CH2. I'll write here CH2, CH2. This is one of the example is there. Second example I will write CH3, CH2, CH, OH, CH3. For example, I will write CH3, CH3. Here also write OH. One more example is there. C2H5, O, C2H5. And fourth one I will write CH, triple bond C. Here I write C, double bond CH2. 1, 2, 3. Here I should write according to valence number 1 of the hydrogen atom. So these are the 5 examples I showed in the structural form, in the dash form, how to write the bond line structural formula. Look towards the first example. In the example given CH3, CH2, CH2, CH4. So here in this example CHOH is a functional group is there. Remember one thing, whenever the functional group is there, whenever the any heteroatom is there, while writing the bond line structural formula, you have to write as it is. And they are shown by zigzag line. So how many number of carbon atoms is there? 1, 2, 3, 4 carbon. It is a part of the functional group. So how to write right now bond line structural formula? See, 1, 2, 3. Alright, 1, 2, 3. 1, 2, 3. Fourth one is the functional group. 1, 2, 3. Fourth one right now. C double bond O H. This is called bond line structural formula. Next example I will write here. CH3, CH2, CHOH, CH3. In this particular example, you will find OH as a functional group. OH as a functional group, alcohol as a functional group. Okay, so how to write right now? Very simple way to write or to represent the bond line structural formula. First of all, you have to write the number of carbon atoms 1, 2, 3, 4. Is that double bond? No. Is that triple bond? No. So, first of all, you have to write the 4 carbon atom by zigzag manner. 1, 2, 3, 4. 1, 2, 3, 4. Each terminal line or ends indicate CH3 group. 1, 2, 3. 1, 2, 3. At third position, OH group is there. This is called bond line structural formula. Next example, CH3, CH, CH3, OH. In this particular example also, you will find OH group, alcoholic group as a functional group. So how to write right now the bond line structural formula? I will give you the number 1, 2, 3. Right by zigzag line. 1, 2, 1, 2, 3. Okay. You remember here 1, 2, 3. In the structural formula, the OH group is attached to the second carbon atom. So here also I will attach the second carbon atom. The name of the compound is propan 2OL or isopropyl alcohol. Next one, C2H5 O C2H5. So what is the C2H5 is there? That is given in the condensed form. First of all, you have to write on the structural form. How to write C2H5? How to split C2H5? Remember, C2H5 in that you will find 2 carbon atoms and total 5 hydrogen atoms are there. So you have to write in the structural form CH3, CH2O, CH2, CH3. Then you can write very easily the bond line structural formula. So first of all, I will write in the structural form right now CH3, CH2, oxygen atom, CH2 and CH3. Here in the condensed form you will find C2H5. Here also you will find C2H5. Now how to represent the bond line structural formula? Here also 2 carbon atom is there, right hand side. There also 2 carbon atom is there in the left hand side. So to represent the bond line structural formula, you have to write in the zigzag line 1, 2, 1, 2, 1 and 2. At the third position, oxygen atom is there. Next CH2 and CH3. This is called bond line structural formula of that particular compound. Next one is the fifth example. In this example, you will find triple bond and double bond. 3 dash also is there, 2 dash also is there. So how to write down the bond length structural formula? So first of all, if you want to write bond length structural formula, use the number of 1, 2, 3 and 4. 4 covalent atoms are there. Now how to write right now the bond length structural formula? First of all, you have to write on the zigzag line 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Alright? First and second. Across first and second carbon atom triple bond is there. Alright, here triple bond. And also you will find third and fourth carbon atom as a double bond. Here also I will write a double bond. So this is called bond line structural formula. So next we will discuss three-dimensional representation of the organic compound. To explain the three-dimensional structural formula of the organic compound, 3D representation of organic compound. Three-dimensional representation of the organic compound. To study for this compound, I am going to consider the simple example of methane molecule. Example methane. You know methane CH4. I'll write the structural formula. Carbon atom is there in the center atom. Here also hydrogen atom is there. 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 So these particular method, how one can represent the 3D structure. Okay. So for the 3D structure, so they will write in this fashion. First of all, they will write the carbon atom. Total number of bonds present in the methane is 4. Out of 4 bonds, 2 bonds they are shown by a normal line, and another bond is shown by a solid wedge line, and one more bond are shown by dashed line. So these, it is called normal line, and this particular line is called solid wedge line. This is called dash wedge line. Dash wedge line and solid wedge line. This is the methane compound. Carbon atom with the center atom is there. 4 bond is there. This particular methane compound, how to represent the 3D structure? In the 3D structure, so what are the methane compound is there? That formula, a compound that are holded on the plane of the paper or plane of the board. Out of 4 bond, 2 bond are placed on the plane of the paper or plane of the board. They are indicated by a normal line. So these 2 lines, they are placed on plane of paper or plane of the board. Means indicate, means what? So out of 4 bonds, so whatever the 2 bonds are there, 2 carbon hydrogen bonds are there, they are holded or placed on the plane of the paper. Another bond, they are shown by solid wedge. What indicates solid wedge? Solid wedge in the 3-dimensional structural form indicates that bond is towards the observer. So this solid line, it indicates that bond towards the observer, and whatever the dashed wedge line is there, that indicates that bond away from the observer. So likewise, any organic compound, they can be represented by solid wedge line and dashed wedge line. So you have to remember, so what is mean by solid wedge line, what is the meaning of solid wedge line, and what is the meaning of dash wedge line, and whatever the two lines what it indicates. So here I am going to start. Remaining part I am going to discuss in the next class. Thank you.